All right, so here are your last two examples for the applications. And so this example says, to measure the height of a mountain, a surveyor takes two sightings of the peak at a distance of 900 meters apart on a direct line to the mountain. So this one's really nice because it gives us a diagram. Sometimes they don't. So the first observation results in an angle of elevation at 47 degrees, and then the second is 35 degrees. The person is 2 meters high, so we want to know the height of the mountain. So if you have to come up with your own diagram, think about it. If you're closer to the object you're looking at, you would have to look more up. So that should be a higher degree. So because sometimes it can be confusing of where to put these two, right? But if you're closer, your head has to look more up. So that should be a larger degree. Okay, so what we have here is we have one big triangle, big right triangle, that is. We have a smaller right triangle. Then we have this oblique triangle right here. So I see a right triangle, my brain wants to go, okay, I can use sine, cosine, tangent, but I don't have enough information, all right? So what I need to figure out is, it's up to you. Either you're gonna figure out this hypotenuse for the smaller right triangle or this one, all right? So again, it's totally up to you. You're gonna get the same answer. So I'm gonna go with the bigger right triangle. So I'm just gonna label that X. All right, well, there's some things I can figure out. So I have 47 degrees, I have that 35 degrees. I can figure out this angle because it forms a line. So that's gonna be 180 minus the 47 degrees. And I can do that in my head, but I'm not going to because I know me. That's going to give me 133 degrees. Okay, I'm not sure if that, I'm just going to keep solving for angles. So now I could also find this little piece because this whole triangle, so that is 180, take away the 35, take away the 133. So 180. Take away the 35, take away the 133, gives us 12 degrees for that little piece. And maybe I'm solving for too much, but it's good habit. So I could also figure out this angle because it's a right triangle. So I have 180, take away the 47, take away the 90. So that's 43 degrees. All right, so what's going to help us find some missing lengths? Because I have to, my whole goal, just to remind us, is to find this height of the mountain. All right, well, if I want to find X, I'm going to focus my attention on this oblique triangle right here. And I can use law of sines, right? So I could do sine of 12 degrees over that 900 equals, well, if I'm looking for X, I would do sine of 133 degrees over X. And then what we've done in the other videos and in class, we can cross multiply. So I get X times sine of 12 degrees equals 900 times sine of 133 degrees. And then I divide both sides by sine of 12 degrees. So I end up getting X is equal to 900 times sine of 133 degrees over sine of 12 degrees. And so I'm going to go ahead and go to good old Desmos. And I'm actually going to pull this up next to it. So it looks like I have, let me just do this. Okay, maybe not. Hold on one second. Okay, 900 times, I'm going to move this. Maybe I can let, I don't know why this isn't letting me move anything. And I don't want to start over, so I'm very sorry. Okay, so I'm going to open this, and then I'm going to go ahead and pull this next to it. It's funny that it's not letting me. Okay, 900. Sorry, students. There it is. Okay, phew. All right, 900 times sine of 133. Close that. Divided by sine. And we talked about how this is the same thing of 12 degrees. So we get x is about 3,165.86. And that would be meters. Now, going back here, that isn't what they wanted us to find. Remember, we want to find the height. I just had too much unknown. So I had to find some other length. That 900 isn't part of a right triangle. It's just part of that oblique triangle. So now I can focus my attention on this huge right triangle. Because now I know that hypotenuse, I'm looking for that height, and I can go ahead and stand at this 35 degrees. So if you're at 35 degrees and you're looking for opposite and you have your hypotenuse and it's a right triangle, you are allowed to use, let me change colors so it stands out, sine of 35 degrees equals opposite height over, and maybe I should use my approximately symbol because I did round, 3,165.86. And now you've solved for your height. So your height is 3,165.86 times sine of 35 degrees. So we end up getting, let's see if I can do this without driving us mad. Okay, good. So again, I'm going to use that entire answer. So answer times sine of 35. And I get 1,815.86. All right, now the key thing is that that's the height we found, but remember, we still have 2 meters with our surveyor. So the total height, we want to add that 2 meters. So the height of the mountain, again, full sentence when you're solving applications, is approximately, because I did round, so I like to say approximately, about 1,817.86, and our units are meters. Hi. Okay. So the next example is very similar, except it's not giving you a diagram. So I encourage you, after watching that past example, example 4, go ahead and pause this and see if you can come up with it on your own. So Pat needs the height of a tree before cutting it down to be sure it will not fall on top of a nearby fence. The angle of elevation of the tree from one position is 30 degrees. And then you move 40 feet further, or farther, excuse me, along this path, and it's 20 degrees. So here's your tree. All right, so we want to know the height of the tree. So we have one sighting, and then we have another sighting. And again, when we talk about height, it's always perpendicular. Forgive that terrible bottom line. Let's make that look a little bit better. So again, this is where it can get confusing. Where do you put the 30 and 20? Well, if you're closer to the tree, you have to look further up. So that's why your 30 degrees would go here and your 20 degrees would go here. And then this is your 40 feet. So you can see how it's set up pretty darn similar. We need to find the height. So what we're not taking into consideration is how tall Pat is. So that's okay. We're going to, I guess, assume Pat is flat with the ground. So again, your choices to get the ball going, to find that height, is either you find your hypotenuse for the smaller right triangle or for the larger one. It's completely up to you. I'm going to just show solving for the smaller one so you can be convinced that it does not affect your answer. So I'll label that X. Okay, so to get the ball rolling, I have to use this oblique triangle to figure out X. Well, if that's 30, we know this is 150. Well, if that's 150, that's 20, 70, 170. So we know this is 10 degrees. So my full ratio is sine of 10 degrees over 40 equals, I'm looking for that X, so that's why I have to do sine of 20 degrees over X. Cross multiply, I'm going to save us time. That ends up being 40 times sine of 20 over sine of 10 degrees. So let's go ahead, get out of there. So 40 times sine of 20 divided by sine of 10. So I get 78.78. So I'll just say 78.8. Depends on how they want us to round. Okay, so now what we found is, I'm going to go ahead and replace it. We know that X is about 78.8 feet. Now this is really cool, and I think you'll agree. Here is the small right triangle we're working in. Well, if this is 30, this is 90, that forces this to be 60. And you're in a special right triangle. So you could use that relationship. Okay, so one way we could solve this, so that's the really cool thing, is remembering this relationship, which I'm trying really, really hard to make sure that you do. If that's my hypotenuse and I'm trying to find my short leg, right, because that's across from the 30, because of that relationship, 78.8 feet, and I can divide it by 2. So let's go ahead and do it. 78 point, or let me just actually go back to my decimals. Enter. So I'm going to take my answer and I'm going to divide it by 2. So I get 39.39 or 39.4 feet. This is how tall my tree is. Now say you're like, no, Stephanie, I would never have been able to recognize it's a special right triangle. Hopefully no one's saying that. Forgive that terrible handwriting. We can also solve it using the sine function, because, let me go ahead and get this guy, because here's the angle we're standing at. Okay, I always want to stand at the angle that's given to me. So just in case I'm tired and I messed up that 60, but this one was given to me. I'm looking for opposite and I have my hypotenuse. So I can do, and it's a right triangle, so I'm allowed to do sine of 30 equals, and I'll use approximately since that hypotenuse is rounded, opposite over hypotenuse. You go ahead and isolate that H. And let's see what we get. So 78, and I'm going to use the whole answer so I don't mess up anything. So I'm just going to type all those decimals I see. 462,024 times sine of 30. Doesn't that feel great? You get the same thing. So 39.4 feet. So the height of the tree is about 39.4 feet high. All right, thanks for watching. See you next time.